happens here, okay, is called this is called VSEPR theory. Now, what is VSEPR theory? Now, it stands for valence shell electron pair repulsion theory. Now, according to this theory, okay, they have stated, we know that electron and electron, okay, when they come closer to each other, they will repel. They don't like each other. Okay, they will repel. But we have learned now, okay, that electron they are arranged in pairs. When you are there is a bonding, they are arranged in pairs. So similar, if you have electron in pair and electron in pair, when they come closer to one another, they will repel. Okay, they will repel. But since we have two different types of electron pair, okay, they have found out that the repulsion, okay, are different. Okay, the repulsion are different. How different are the repulsion? They have said that lone pair and lone pair, okay, they repel more. Okay, they repel more compared to lone pair with bonding pair. And these two pairs, okay, they repel more compared to bonding pair and bonding pair. Okay. Now, this one I can demonstrate using, okay, using this example CH4, using H2O and ammonia. Okay, I can demonstrate this using this. Now, according to CH4, if I want to actually draw, okay, the structure of CH4, do remember the electrons, they like to rearrange themselves so that they are comfortable with their position. Okay, for example, if you really hate one person, will you go and sit in front of that person? Of course, no, right? So you try to go and actually maybe you try to actually sit behind the person so that you won't be able to actually see that person. Okay, so we try to actually rearrange yourself so that you get the most comfortable position. Okay, most comfortable position. Now, if we have CH4, okay, if I have these electrons, so if I have CH4, normally we draw CH4 like this, but this is not how it is arranged in space, this is not the actual arrangement of carbon and hydrogen. Okay, why? If you look at it just like this, we can actually see that the bond angle, what is the bond angle? What do you expect? Even from this diagram itself, what do you think the bond angle?
I'm not sure, sir.
Just use your maths. Okay, if you have something like this, okay, and you have this, okay, what will be the bond angle?
45 degree.
40 or 90?
Oh, 90.
90, right? Okay, so we are expecting to be 90. Okay, we are expecting this to be 90. But okay, I told you, okay, they need to actually find the most comfortable position. Yeah, for CH4, okay, the most comfortable position is not 90. Okay, the structure will look like this: H over here, H over here. Take note, two same lines. Okay, it means they are on this paper or on this iPad. Okay, on the screen. And there is one something like this. Okay, I draw like this so that it is, just imagine they are coming out from your screen. Okay, they're coming out from your screen. And this dotted line, just imagine they are going behind the screen. Or to make it simple, it's similar like your tripod stand that you use for camera.
So it's like a
It's a 3D
3D
structure.
shape.
Okay, it's a 3D structure. Okay, whenever you have time, okay, if you have the time to spare, if you want to actually find out the bond angle, you go and find out what is the bond angle of this. Okay, the bond angle is going to be 109.5. And this bond angle is greater than 90. So they tend to actually follow this structure, the tripod stand structure, compared to the 90 degrees over there. So this one we have a name for it. Okay, the name is called tetrahedral. Later we discuss about that. Okay, but whatever it is, okay, I just want to actually highlight that for CH4, okay, they are going to have a bond angle of, okay, the bond angle of 109.5. Okay, 109.5. Now let's actually look at water. Or before water, let's actually look at ammonia. Okay, ammonia, they have one lone pair. Okay, how to draw? I think this one you should know by now. Okay, they have 3 bonding pair. And to be exact, if you want to actually draw the way that I have drawn over there, so it's supposed to be something like this coming out from the paper. And then this one should be dotted line. Okay, how it looks is like a tripod stand where the stand is already broken. Okay, it looks like something like this. Okay, it's already broken, so it looks like something like this. And then, okay, we expect, okay, if the stand is already broken, I think the bond angle must be still 109.5, right? But, okay, according to this Vsepr theory, let's actually apply this concept. Now, this one is bonding pair just now. This is also bonding pair, bonding pair, bonding pair. But now, this is lone pair. This is bonding pair. Okay, it means now, okay, we know that, okay, lone pair and bonding pair repulsion is greater than bonding pair and bonding pair. It means that this particular angle should be greater compared to this angle. Why? Because the repulsion, they will push this greater. So it means this angle is no longer going to be 109.5. It's going to be much more smaller than 109.5. Does it make sense? Because the repulsion of the lone pair and bonding pair is greater. Okay, so it's going to be, even though it's similar like tetrahedral or the similar with the 4 bonding pair, but now because of the presence of lone pair, the angle will become smaller. How small the angle will be? Okay, the angle you need to memorize is 107 degrees. And when we say bond angle, yeah, sir, how about this angle? This should be bigger. Should we memorize this? Now, when we say bond angle, we are referring to the bond angle between bonding pair and bonding pair. So it means we are interested with only this angle. Okay, only with this angle. So let's actually have a look at the angle of H2O then. Oxygen, 2 lone pair, H, H. Bonding pair, bonding pair, lone pair, lone pair. We just have learned that according to VSEPR, okay, the lone pair repulsion will be way bigger, okay, compared to lone pair and bonding pair. And then this is going to be the weakest. Okay, so it means that it is going to be way smaller than what you have over here, which is 107. Okay, why? They will push it greater. So of course, this one will become way smaller. Okay, what is the bond angle that we are expecting? This one is going to be way smaller than 107. It's 104.5. 104.5. So all these are using this Vsepr theory. Okay, Vsepr theory states that, okay, if you have this bonding pair and so on, there will be some sort of repulsion. Okay, repulsion. So since I actually taught you this, okay, so now let's actually have a look at, okay, all the shapes that you might get, okay, if you have certain bonding pair and lone pair and so on. So let's actually start with that. Now,
Sir,
yes.
so then does it decrease by 2.5 degrees every time?
For this case, yes, you can take it this way. Okay, it's only
But not every
for
time.
okay, for your syllabus. Okay, do remember you need to know about CH4. You need to know about ammonia. You need to know about water, the one that I showed you just now. So you can memorize the numbers. Okay, but in the past year papers also, they can actually ask you any example with the similar bonding pair and lone pair combination. You should be able to predict also using those numbers. Okay, sometimes, okay, you have a situation where you have A, then you have B, 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 and then in the past year paper there was one time they actually only have one electron over there instead of two electrons. So they asked us to predict this. And you know what are the answers that are going to be accepted? Okay, we will assume that this is something like lone pair, even though they are not lone pair. Okay, we assume. So when we assume this one as a lone pair, we actually take it as, okay, something similar to ammonia. So the answer will be 107, but they obviously don't actually put it as 107 is the ultimate answer. No. Okay, they will always give a range. Now, we know that this is only one. Okay, of course, the angle should be much more bigger than 107. So they actually put, okay, any number from 107 to 109 is accepted. But 109.5 should not be accepted. Because why? Because it's supposed to be bonding pair, 4 bonding pair. Is that clear? Okay, I hope I answered the question, yeah? But anyway, it's not important for now, okay? When we do questions, then we will see all these kind of things. Okay, let's actually focus on what is important for now. Okay, the important part for now, if I want to actually have, let's say if I have a molecule and then they have two bonding pair. Okay, two bonding pair. Example of those molecule will be BeCl2. Just now we have actually we went through about this example, BeCl2. So what is going to be the shape and what is going to be the bond angle? You need to know. Okay, beryllium is going to be group 2, so something like this. So Cl, Cl. Okay, I'm not going to draw everything. You always refer to the center atom. Okay, you don't worry about, okay, the atom beside. Okay, even though they have a lot of other lone pair, we are looking at the center atom. According to the center atom, you have how many bonding pair, Frederick?
2.
Yeah, you have two bonding pair. So therefore, if you have two bonding pair, the best option that you can have is to rearrange yourself in this form. Okay, this is going to be the bond angle is going to be 180 degrees. The shape, we call it as linear shape. Okay, this one of the example only. Okay, so you should be able, whenever they give you any example, you should be able to identify. Okay, this is one of the example. Let's actually go for 3 bonding pair. 3 bonding pair, let's actually look at group 3. So maybe BF3 is one of the example. So if I have BF3, okay, if I just simply draw something like this, okay, F, F, F. I'm not drawing everything, okay, all the valence electron, because we are interested with the center atom. The center atom is B, so which is going to be, you have 3 bonding pair. If you have 3 bonding pair, okay, the best option or best situation that they can be is going to be in this form, which is the bond angle is 120 degrees. What do we call this shape? Okay, this is going to be trigonal because it's like triangle, trigonal planar. So I told you what are the things that you need to memorize, eh? Memorize the bond angle, memorize the name. Okay. Let's go on with 4 bonding pair, but 4 bonding pair we already learned, yeah, just now. Okay, I will actually just write it down again. 4 bonding pair, okay, the one is that we have learned is CH4. Okay, CH4. So if I draw, okay, I just draw here directly, C, H, H, something like this, like this. So the bond angle is going to be 109.5. The shape, okay, we don't call it as we don't call it as tripod stand. Okay, we call it as tetrahedral. Okay, tetrahedral. We have 3 variations for 4 bonding pair, like what we actually have just now. 4 bonding pair. Okay, we also have 3 bonding pair, 1 lone pair, which is going to be something like ammonia. We have learned this just now. So you have nitrogen H, H, H. The bond angle, okay, is going to be 107 degrees. This one we call it as pyramidal. As I said just now, we have 3 variations of 4 bonding pair. There's another one, 2 bonding pair and 2 lone pair. Okay, this is another variation. So this one is going to be H2O. So if I put O, H, H, like this, the bond angle that we are talking about will be 104.5. And the shape of this, okay, the shape of water, okay, in this case, the molecule of water is going to be bent. In your syllabus, there are 3 terms accepted: bent, or non-linear, or it looks like V, okay, the V that is actually flipped, okay, so it's actually called V shape. Which one I want you to follow? Okay, I prefer you to write bent. These are the variations. Okay, so let's actually go for the 5 bonding pair. Now, if you have 5 bonding pair, we are talking about 5 valence electron. Okay, the best way is going to be looking at PCl5. Okay, PCl5. Phosphorus is group 15. So you have 5 valence electron. 1, 2, 3, 4, 5. Okay, Cl, 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 Cl. Okay, of course, I don't want to actually draw everything. But the best position or best way to rearrange them, okay, is in this way. P, arrange them in form of triangle. Okay, Cl, Cl, or let me draw the other way around. Okay, imagine there is going to be something like this. P, Cl, Cl, Cl. Okay. And one of the Cl is on top of the triangle. Another Cl is at the bottom of the triangle. It means that, okay, the bond angle, okay, there is 2 bond angles. Okay. If you have like something like this, imagine you have a triangle and you put a stick on top and you put another stick below. Okay, so what is the bond angle of that stick and the plane? That is 90. But if you look at the triangle, what is the bond angle there? So that is going to be 120. So there are 2 bond angles over there, 90 degrees, and here is 120 degrees. So this shape, okay, we call it as, okay, I'll erase this part. This one we call, okay, since there is actually a triangle, we call it trigonal. Trigonal. But there is up and down, is bipyramidal. Okay, trigonal bipyramidal. And almost there, another 2 more. Okay, so the last 6 bonding pair. Okay, 6 bonding pair. Example is SF6. Okay, sulfur is group 6. Okay, so if you want to actually have 6 being arranged, imagine something like earlier, but now there is a square S, F, 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 F. On top, there's another F. Below, there will be another F. So this one, if you have a square, so we divide, each one is 90, and this one is also 90. So the bond angle of all is going to be 90 degrees. Okay, 90 degrees. And then the shape, okay, we call it as octahedral. We have variations, okay, based on past year paper. Of course, all this you don't get from the textbook, but this one is really required. I have actually put it down for you. Okay, so some of it you will learn based on questions only, but I have put it for you already. Okay, one example is going to be one more example is when you have maybe 4 bonding pair, 2 lone pair. Okay, 4 bonding pair and you have 2 lone pair. Yeah, Josh, Ken. So if you have 4 bonding pair and 2 lone pair, example SF4, or 4 bonding pair, 1 lone pair, or something, any kind of example other than SF6. Yeah. Okay, let's say in this case, let's actually see SF4. SF4 is it how many bonding pair? Okay, let's actually see how many bonding pair. So here sulfur is group 6. Okay, sulfur is group 6. So if you have 6, okay, electrons, okay, and then 4, it means that there is 1 lone pair and then 4 bonding pair. Okay, in this case, I'm going to erase this part. Okay, this one I've seen this in one of the past year paper. Okay, I've seen this in one of the past year paper. You have 1 lone pair, for example. It can be 4 bonding pair, 2 lone pair, doesn't matter. Okay, doesn't matter. What happens over here is, what is the best arrangement for this? Okay, the best arrangement for this is sulfur, and then they have like this, all the 4 arranged here. The electron stays on top. Okay, or if you want, okay, they can actually stay 1 electron, put it here, 1 electron, put it there also. Okay, doesn't matter. Okay, that's why I'm not focusing on this. Okay, so they actually ask you to find tell what might be the shape. Okay, this one is based on the past year paper. The shape of this, okay, this is called, okay, it's a square. Okay, Michael can square, and it's called planar, square planar. What is planar? Planar means in one plane. Okay, so just imagine it's like you have a square and a piece of paper. Okay, that is actually just going to be just like that. Okay, F. So this one will just stay there. Okay, now you have all these example. Okay, I want you to actually identify from these examples which one will be a 2D diagram. Okay, which one do you think is a 2D diagram? 2D diagram means they are planar. Planar means they can be formed on a piece of plane. Okay, so 2D is planar. Now linear, are they planar, Benedict?
Yes.
Okay, linear are planar. I'm going to actually circle over them. Trigonal planar, Ryan, is it planar?
Yes.
The name is a giveaway already. Okay, trigonal planar. Okay. Is tetrahedral planar? Even?
No.
No, it's a 3D diagram. Yeah. Is pyramidal planar, Nathan?
No.
No, it's a 3D diagram as well. Okay. Is water, okay, bent V shape or non-linear? Audrey, is it planar or non-planar?
Planar.
Yes, very good. Okay, it's planar. Okay, it's planar. It can be formed on a piece of paper, V. Okay. How about trigonal bipyramidal? Are they planar or non-planar? Megan?
No.
Yeah, they are non-planar. Octahedral, Arvin?
No.
Non-planar, okay. How about the last example, square planar? Michael? Planar or non-planar? Michael?
No. Planar.
Planar, because it's already a giveaway, yeah, the name itself. Okay, but it's not found in the textbook. But they have asked twice, okay? They have asked twice about square planar. You won't be able to find square planar, the term, even in the textbook. Okay, so take note, okay? This one I give you as extra, okay? Anyway, you have all this structure, but I want to actually discuss certain things about the naming. You know, sometimes we actually learn something, we don't actually look at the naming properly. Okay, if you look at here, linear is one straight line, so it's a line. Okay, linear, so that's why it's a line. Trigonal planar is a triangle. Yeah, so it's actually, it forms a triangle. Okay, if I just put like this, it forms a triangle. Why this one is called tetrahedral? Tetra means what? Even tetra means what?
What?
Tetra.
What?
What is tetra? Michelle? Michelle V?
Is it 4?
Yeah, tetra is 4. Okay, why they what is hedral? Anyone knows about hedral? Maxwell? It's actually 4. Hedral means faces. Okay, 4 faces. Why 4 faces? Take from here, you put down to here, one face. Take from here, you put down, there's another face. Take another here, another face, 3 faces already. And the last one, 4. So it looks like it's like a pyramid kind of face. Yeah, there is total 4 faces. Now, why I'm actually teaching you this, because last time I had one student asking me, sir, it's only 6. Why is named octahedral? We last time learned octa is what? What is octa? Christopher?
Octa is 8, right?
Yeah, octa is 8. So, sir, why octa is 8? Why suddenly is 6 bonding pair? And why we call it octahedral? Why is not hexahedral? Okay, it's a very good question. Basically, it's like this. You put like this, one face, 2
Is that
face,
because when you
3, 4, yeah?
Yeah.
So 4 faces on top, another 4 faces below. Total 8 faces. Can you guys understand this? Okay, that's the reason why they are called octahedral. That's the reason why even this one is called pyramidal, because it looks like pyramid. Okay, pyramidal. V-shaped bend, no need to talk about it. Okay, but you see, bipyramidal. One pyramid on top, another pyramid below. Bipyramidal. Trigonal bipyramidal. It's 2 pyramid with the triangle base. And square planar, I think no need to talk about it. It's just actually square. Okay. So now, if I actually summarize this, okay, can you guys tell me one by one? Yeah. So Kevin, if you have 2 bonding pair, what is the shape? Kevin, are you there?
Linear.
Okay, linear. Okay. Giuliano, what is the bond angle?
180.
Okay, very good. If I have 3 bonding pair, Sharon, what is the shape?
Tetrahedral.
No.
No. Trigonal planar.
Yeah, trigonal planar. The bond angle, Sharon?
109 point.
No, 120. I'll give you time to memorize this, okay? But that's why I'm actually asking you again and again, yeah? So you must actually memorize this, okay? So 3 bonding pair, trigonal planar, okay, 120 degrees. Okay, the one that you mentioned just now was actually 4 bonding pair, yeah? So 4 bonding pair, Thompson.
Tetrahedral,
Okay, tetrahedral, the bond angle?
109, 107.
109.5, okay, 109.5. So we have variations of 4 bonding pair, 3 bonding pair, and 1 lone pair. Okay, that is going to be Frederick. What is the shape?
Band,
No.
pyramidal,
Pyramidal. The bond angle?
107.
Yeah, 107. Okay, Nicholas Chai. 2 bonding pair and 2 lone pair is another variation of 4 bonding pair. So what is going to be the shape?
Bent.
Bent. Okay, you have 3 different names: non-linear and
V-shape.
also V-shape. Okay, so the bond angle is Nicholas.
104.
Yeah, 104.5 degrees. So we go for the 5 bonding pair. Okay, for 5 bonding pair, Benedict, what is the shape?
Wait.
Okay, I already wrote over there. Okay, trigonal bipyramidal. What is the shape? The bond angle. There are 2 bond angles. Okay. So Michael, how about 6 bonding pair?
Octahedral.
Octahedra, and the bond angle?
90.
All 90. Okay. There is one variation which is 5 bonding pair, 1 lone pair, or if you have 4 bonding pair, 2 lone pair, okay, they are going to actually be the same. Okay, the shape is going to be Nathan.
Square planar.
Yeah, square planar, and then the bond angle is always 90. Okay, this one is extra, so I put it as extra. Okay, these are the things that you need to know. Okay, I have actually put it as a video as well. I even recorded this video also. Okay,